Well, as you can see, well, obviously, thanks everybody for coming. One of the lessons one gets from talks is that don't put any text on, just show pictures of old friends at the party that look funny. And so I will try to continue with that. There is a little bit of science in this, but I will conveniently skip over it. And I will take a path through some of the nice pictures that will remind me and show you what really is the great joy of doing science. Yes, the sense of discovery and all of that, but it's really all about the interaction of colleagues, and it's really fun. So my title, that's TBD, is Paths in Our Cosmic Landscape, and is an antidote to George at 60 years of Bond aging. And I will not go back into the prehistory, but just say something about the Pasadena years. This is a picture of when I went for 6 months to Denmark. Actually, this was taken in Israel for those of you with Israeli eyes, and can see that it's
yeah, there's a that's all right. That's it. That's it.
So the wild days of LA in the 70s. One ubiquitously had to have one's hair growing a little bit long, but I did clean. You can't see it. I did. Well, it doesn't matter. I think this is the only one, and probably it's best that this is dark because I really didn't want you to see it. It just shows that I sort of cleaned up, except for the hair. But by the time
okay, now kill the regular lights.
Yeah, do that in there. Number 1.
Okay.
You?
By the time I got to Cambridge, I, of course, couldn't be like this because I was in the mother country. And this was at a May ball. You know, these all-night adventures that were really fun. You had to pretend and do dress up, but they were pretty raucous in any case. I'm going to read to you the introduction to my thesis because at some level it's a motto. And when I beheld my devil, I found him serious, thorough, profound, and solemn. It was the spirit of gravity. Through him all things are ruined. One does not kill by anger, but by laughter. Come, let us kill the spirit of gravity. Nietzsche. And it was because my thesis was all about neutrinos trying to escape the washing down into maybe either a neutron star black hole state and trying to get into free space with lots of freedom. And so I was transported when I got to Berkeley into the lightness and exhilarating freedom of unbridled cosmic speculation, which was cosmology of that time. I was armed with lots and lots of theoretical tools, which were a great thing, and the universe was our oyster, and the advantage was that there was not that much data, and so we got to play. The younger people in the audience are really confined by the fact that the subject is so successful. You don't get to play with arbitrarily many models, but we're still looking for nuggets within the models that we are working on. There were two themes, and it is actually one of my ways of trying to think about life, the universe, and everything. two interesting aspects of being. There is the collective phenomena of wholeness, interaction, one universe, and then there is entropy creation, another aspect of the splitting of coherent things into the multivariate many. And so those are two interesting opposing aspects, which are, in my view, obviously fundamental aspects of the universe. And at some level, one is trying to inform one's theory anyway by trying to follow these things through. So the other aspect, as I follow through things, is that, as you can see, I'm now an experimentalist by having seen these pictures. But really, the modus operandi is that I wanted to learn about the experiments and observations. The only way for doing that and actually paying attention to these papers was by doing the implications. And so that's what I've been doing for a long time. And the science of the entropy expanded a bit to be not just theory, but also data, all encoded in probabilities. And at a conference recently, I said that what we were doing, combining the probabilities of this and the probabilities of that, is the cosmotician's agenda. And surely many of you have been accused of being cosmeticians rather than cosmologists, so it's just a play on that. I'm going to go back to somebody who is a great spirit for me. Willie Fowler was my thesis advisor, and he has been invoked at the meeting. These characters up here are the great nuclear physicists. This is IOTA, Institute of Theoretical Astronomy in Cambridge in 1967. Those of you who know will know who all these people are, and I won't go through it because that's not the nature of the talk, but the great development of that generation was to understand how all of the atomic nuclei came into being through supernova, and Jim, who is now left, through the Big Bang itself, creating the lighter elements. Oops. Okay. What's the method? Why is it that the physics?
Are you running some simulations in the background?
Well, he's already analyzing the Planck maps.
Okay, let me continue with this picture. Well, I'll continue with the story, and hopefully we will get this coming up. So it's, of course, ironic that as I was discussing entropy, entropy came down to interfere with the talk.
You came too close to truth.
Right. So Fowler. So I'm going to continue with that theme for a moment, and I was going to, which you will see in a second, but I'm going to talk a little bit about an aspect of Fowler and what he engendered and other people engendered. And that is the idea of an institute that would be focusing on advanced researchers who were young, postdoctoral fellows. And so Kellogg and Caltech of the 1960s, essentially everybody in the known theoretical universe came through the Kellogg ferment of ideas that was going on. So John McCall was there at that time, and then went on to the Institute for Advanced Study and took that model with him. And
You gonna tell us about Paris while we're with you?
I may run out of time. CITA, and the etymology. Both Scott and I were at Caltech. We came under this influence, that place. Willie and Fred Hoyle conspired to transport that spirit to the Institute of Theoretical Astronomy in those days. Peter Martin was a graduate student there. And I'm also pointing to Dick Henriksen, of course. And so we all had the idea. Scott spent considerable time in the Institute for Advanced Study. And so we decided that CITA should become, as much as we could, a postdoc institute. What is absolutely startling is how can we afford to have 24, which is about the number we have now, at CITA. It is a totally amazing thing that has occurred, and it has created this fabulous firmament. Another fundamental ingredient in the combination, as you heard last night, is the Canadian Institute for Advanced Research, the Cosmology and Gravity program. It started with Unruh Israel. I want to point to Peter Martin's altruism, because he created, with Bill Unruh, a proposal, and then said, we won't stick my science in, which means he won't get any money. And Peter's like that. Fabulous. There was a meeting. seeds that it's stealing away. Jim Peebles, Mark Wise, people like that in the early days. Then, so great, I got to bring my good friend Nick Kaiser on board. I might mention that Andrei Frolov's dad was grabbed from Russia, and that was all a forecasting on my part that I would work closely with Andrei in the future. And that great ultra-early universe guy, Tremaine, as an attempt, well, apart from his unbelievable talents, but as an attempt to try and stem the flow to Princeton, he became the director of the program, and as you all know, one of the great astronomical, very wise since his administrator. He was a fabulous director following on Unruh, and then they had to take a step down. And the other thing I was able to do was to get many, many friends as fellows, scholars, associates, and board members, and many of the people in the audience are among that group. And as has been stated, there has been many great, great meetings, and only a few bruised and broken bones. Fraser Mustard was the guy that came to Stanford that sort of pulled me out from my enjoyment of the Californian weather. And what enabled the whole thing is Peter Allen, who you heard from last night, might be in the audience. Really visionary and a good friend. I thought that I would regale you, since I have this completely unjustified view that I make complicated view graphs. And what's complicated about this? Anyway, when I was at George's opening of the Kavli Institute in Cambridge in November, one of the pioneers in in-body studies, Farah Arseth, who was there in Cambridge through the whole oil period and continues to be so, told me that there was something called the Willie unit. And the Willie unit was complexity of slides. Now, I don't really remember Willie's complex slides, but Art McDonald verified this today. What I remember about Willie's presentations is the very first thing he would do would be to tell a joke. It was a completely stupid joke, but it was a mechanism for connecting with the audience. I wish we could all do that. And then it got into, I guess, complex things. The other thing I remember is, I think it was this, but it wasn't. He had a picture of a big bottle of scotch. And I think it might have said bottled and bond, but whatever. Anyway, Willie units, and probably the nicest thing that was said about me, among all the things that were untrue, is what Art said, in which he said CITA and CIPAR were carrying on the tradition of Willie in terms of having a lot of fun doing science. So there is a Willie unit, and I guess you would say there's a bond unit, but I would like to say that the bond unit is a Milli Willie. Okay, microwave background. I have a bunch of people here. The only reason I'm showing this is because even George ages slightly. Look at that guy. Wow, handsome guy. And Joe and Jim looks the same. And Mark Reese got solidified. Okay, you've heard about delta T over T. It was a great time. However, delta T over T, this is the equation I want you to comprehend, you who are younger in the audience. Your delta T relative to me, divided by T bond, is destined to go to 0. So do not think you are immune from the aging process. And it will definitely be zero, almost, by the time T1 goes to T universe. There you go. Okay. The Willie picture with this costume party he was at has been invoked already. And I'm not going to say much about the science of this, but just I think Willie would be very proud of what has occurred in this subject from just this point of view, which we now take so for granted. We forget that this is one of the most brilliant things that came out of the microwave background studies. Namely, that the number of baryons in the universe is in total agreement with the Big Bang nucleosynthesis, that determined by the microwave background and that determined by the CMB. That is a fabulous story and a really nice addition to the whole tale of where the hydrogen, helium, carbon, oxygen, iron, etc., came from. So I think he would love that. Another aspect of the subject, given that we were talking about delta T over T, and that's been talked about, I want to bring your mind back, some of my aging buddies here, that they were here in 1989, in April 28 and 29. Those in red are people that have some, I think they're probably around here. And we call it computing cosmologies, but basically the idea was that everything is cosmology, as you all know. And so it was computing anything and everything in the known universe. And it was a recognition of the time that we were on a major change. We had already had lots of computation that was occurring. But the thing that has occurred since then is just totally outrageous in terms of the expansion of our computing and what we're able to do. I have every expectation that the iPhone will be able to do this in the the BlackBerry will be able to do this. Okay, so we have such cosmologists as Matt Choctowicz here, Bill Unruh here, and such cosmologists as Martin Duncan, a planetary guy. And, oh, there's a Boucher and a Carlberg. That was before he started to go after really big telescopes. Notice this. I actually don't think that we could get them out for that specific meeting. I think it was a year later when it came, but you might know about Sergey. Was he here really? I don't think so.
He was here.
We had him here for this meeting? Oh, weren't we great? Because we were the conduit to bring a lot of the Russians here, and it was obviously fabulous. And I'm going to just show you a few aspects of this meeting before we move on. Computing cosmologies. First thing is registration fee, the cost of a dinner, and what subjects were and what things we were interested in. Salad pack, we were trying to do stochastic inflation. In those days, I had the view that we would do early universe calculations. We would pipe it into microwave background calculations. We would then pipe it into gas dynamical and body simulations, and out would come the universe we see. That actually is happening, but only as a collective effort on the part of an arbitrarily large number of people. And as we heard from Simon and Carlos and all of that, this is a total leading edge art, and it has gone such a long way. So yeah, okay, there are issues right now, but man, does it effectively agree with the data. I'm not saying that LCDM is right, I'm just saying that it's got some aspects of rightness. And notice this. There was an entire industry of Berger's equation and the adhesion approximation, but I won't say any more about that. Okay, so then what we got last August or so is this fantastic computer, 30,000 cores, remarkable thing that actually Canada is as leading edge as anybody on computing, given the situation before there was the wisdom to make Canada Fund for Innovation. And Lyman talked about the incredible growth of data volumes that we have to deal with. And so this is our new abacus. And you can all know the web story, and you look at it in gas or other things. But we have a future in which we have to go into the heart of every little tiny bit in that cosmic web to try and actually make use of fundamental physics from complex exponential processes. I'm going to skip over this, just an advertisement. Some of you went to Nick Taylor's talk. Good stuff. Would you say so? Okay. Lyman talked about this period in the microwave background. And we heard about some of the fabulous things that are going on now, the futures, the great launch of Planck, Spider, etc. What an amazing thing, this story, and the volume of data, and everything's compressed on this edge because we have so much that's coming down the pipe. And it's a great era. I'm going to go back for a second. Do you see that?
No, it's on this picture.
I can see it perfectly. This is my good friend, Andrew Lang. And it is just sad that somebody who is so fundamental to the subject is not going to see the full fruition of his labors and our labors. He always pulled out an absolutely fabulous bottle of wine, and there we were celebrating the great successes of Boomerang. And this is just a nice little picture reminding you of the ups and downs, and a Canadian flag sitting here on the second peak, which told us about the abundance of the baryons that Willie Fowler would be very proud of. You may think this looks like me, but let me assure you, that's obviously Bart Netterfield. And there's John Rule, our good buddy, down on the damping tail where we interacted on Akbar, as well as with Boomerang. And down that damping tail, we went on this great tail that Tony Reed had told about with the Cosmic Background Imager. So the story of CITA, and the story of CITA and the CMB is all about young people interacting and having a very good time. You can see these people. There's the list in the audience. There's Vaughn hidden again. And this is Carrie McTavish with Andrew. And Carrie is out to here because a citizen in the future is about to be given birth in Britain, and that's why that carbon carried right here. Right, so once a citizen, always a citizen. Do you remember that? That's our mantra. And it does turn out to be true because everybody likes to come back. So here, there are some citizens. We are taking over Cambridge. And that process is not quite completed, but that's on the agenda, right, George? And there's Kriya. You can see these characters, Lloyd Knox. For this operation, we recruited this Brit, Bernard Carr, and somebody who had a long association, my good friend Craig, that came off. Anyway, so you can see the spirits often flow when the citizens are together. What was I going to show about WMAP? Yes, I was there for the launch, but probably the more impressive thing was the launch of the WMAP 3 paper, because Mike Nolte was not allowed to talk to us for at least a year and a half while we first came to CITA. He does talk to us now. That's Mike. Sharon's over here. You can't really see this, can you? What is this stuff? Sears, Ray McTavish, Olivier Doré, and very good bottles of wine. And we were at the place of the gastrophysical, sous servie, the chef's Planck. Say a few words about Planck. I first got engaged with Planck in 1993 on a sabbatical in Paris, and it's been a remarkable ride. 2014, one of the class papers. It's just an amazing concept. It'll keep us busy. Anyway, this is Francois Boucher. And Jean-Francois Signier, who unfortunately couldn't be here, a citizen in good repute. And that's the way he looked before Planck turned his beard gray. And instead of showing you much about the launch, I'm going to show you Boucher getting ready for it. This is the device that went up on there. You can't see this, but this is Boucher statue after the launch, which had a great success. And I like this picture. This is Boucher. Boucher is fabulous. He's an amazing character, infinite energy. It's Univers, on, and this is passion fruit. That's why I like this picture. Universe and this passion fruit. Okay, we'll skip over this. This is so I'm reminding you of that I have not lost my ability to measure my figures in the units of willies. Except I will say this. What are we after now? We are in quest of the subdominant. We're in quest of the anomalies. And that, hopefully, will become the underlying truth about the fundamental physics of the universe that we find with this movement on high precision. So we go perhaps somewhat beyond that to CDM. This is too complicated to show you. Well, no, it's because, as I said, the only thing that matters is pictures of people and the names of people. But Marzia, you've been lost. I didn't have her on here. Anyway, Marzia, this was Marzia's poster. And what we're looking forward to is there's a good shot at gravity waves. And these are sort of the numbers similar to what George did. Sophisticated, but actually it's got some sophistication. And there is a really strong case for going to relatively small skies. And what is predicted has a bunch of question marks after it. This is for the tensor component, that is to say gravity waves in the universe produced in inflation. And so there's a relatively high degree of theoretical uncertainty. And so it's wide open for the experimenters to determine, which is a good thing since I'm wearing an experimentalist hat as well as are so many of my friends in the audience. Oh yeah, no, there is a lower bound, maybe lower than that, but there's always a lower bound because you can't avoid the gravity waves at some level. So this is my opportunity to take a moment as one searches for R and other things from the early universe to remember 22 years with Lev Kaufman and how much we miss him. And there he is communing with the Sphinx about the mysteries. And I'm just going to say, okay, we did Cosmic Web. But let's just remind ourselves of the remarkable thing that we think about. This, of course, it's a computer simulation. I don't quite have a image of this yet, and the one from Planck is coming. This is the size in this picture of our observable universe. We can't see beyond this. And this is the way we think structure might look beyond what we can see. But what that doesn't show is that in the way beyond, there are probably high mountains and valleys and infinite complexity and topology ad nauseum. And so we get to think about that, and we start our daily lives when we go to work in the morning or in the afternoon on our schedule. One feels very constrained by how small the universe is. That's the theoretician speaking. Although, okay, I'm just showing this again to remind you that I can do this pretty well. And every one of those green things has been an absolute joy to work on. And this one with Lev was just great. And I will skip over that, except that I don't even. Oh, I know what the question mark was. Probably quite appropriate because it was trying to show the at least 6 other dimensions of the universe. And it was actually trying to be an image of that, but instead it's a question mark, and perhaps that's the appropriate way to leave it. The other thing is that, what was the statement of Einstein's? That God does not throw dice. And so our position was that not only does he play a dice game, but he also knows how to do that. Because everything is statistical, as I mentioned, we are cosmic efficient. Skip, except to say, spider, plank, chime, if we're funded. Canadian experiment, absolutely brilliant. Euclid, European experiment. Futures. Forecasting is the word, George, so you can go to sleep. And what can enable futures? So you don't care about this. I'm not going to talk about it. I'm just going to say spider, launch of plank. And the most remarkable image, perhaps, of this meeting was the unveiling of the beautiful, beautiful map that we're getting from Planck. And that is classified. Max, are you in the audience? There's a famous story, but I won't go into that one. Okay, W. We want W. W got complexity, and right at the moment the data is consistent with the cosmological constant. There's Einstein at the edge of the universe laughing at us. Okay, George. No, you see, George is leaving. So skip over that. George, I'll get back to this. George is leaving just as we were about to talk. December 1980. Okay, I'll get back to that. Now I don't have to. Now I can tell them exactly what happened. Okay, this is I'm in the mode of advertising Chime, which is a great, cost-effective Canadian way to go after properties of dark energy, which we hope is going to go. But that's that. Let's just get to those pictures. And I like this picture. That's ACT, and look at that sky. That's the Atacama Plateau, the driest desert in the world. Yeah. Here I am there is 5170 meters, here 40. So I was high in many different respects. It was actually cold. That's my ski jacket. But because I'm Canadian, shed it as we saw this. And so it looks like it's sunny and warm, but it isn't. Not at the Atacama Plateau, not at that height. But there we are, the intrepid Canadian up there doing his experimental best to get those numbers in. I was going to make a joke about that, but I knew it was too cruel. See, we arranged for the data, worked around the numbers, and you think it's land of CDM. Okay, so what do we do with this great stuff? Well, Craig and I, we contemplate along with our ancestor here. And it is just a fabulous time. And I talked about the period leading up, but now on the 2010s and beyond, Jim Peebles said, fill in the blanks if we are lucky. And so my filling in the blanks of that is we have been. We are lucky, and we will be lucky because we have this avalanche of fantastic information that's coming to unveil the depth of the universe. And so back to this. This is what happened in Paris in December 1972. Well, there was George and Nick and Dick and Guru Joe Silk Joe's there, so ask him. And graduate student Albert Stebbins, I showed him this slide just before he had to take away. And our task was to initiate them into the cosmic way. And now, what happened? Uh-oh. I'm out of what I would like to say, though, apart from thanking you all for coming and for doing this, fabulous for all of us at CITA, for all of the returning citizens to come back home, and for our great friends to come here. And I want to make we paid homage to the great Margaret last night, but I also want to say that the new Margaret, well, at least in some sense, is Nina and Candace. We've also arranged for a volcano to keep our European friends in Toronto for a long time. Anyway, thanks for coming.
If anybody wants to share tabs later, there's this morning.